Okay, so this is actually not a lecture, but something uh, I said in the lecture 0 of the course regarding bonus credit. So I want to basically remind you about that and also provide a few suggestions. So in order to detail the gist of the discussion, I have made a little notes on that, and I will try to show you that little notes while I outline the sense. So yes, so I think this will be enough. So I expect that now you can see this screen in which I'm showing you the hello.idk portal with the course code, actually in the student portal. But now let us go to the resources. In this course plan.txt, course plan.txt, here at the beginning, at the end, I told you that apart from the 500 marks that you uh, target to earn through assignments and problem set and experimental study, whatever, there is a there is an extra 50 bonus marks that you can get by doing an optional task, which is a programming implementation. Any of the methods taught in the course. So this 50 marks bonus I will use for later upgrading some of you who might otherwise fall in one grade, and by addition of whatever you earn out of this 50, if your total crosses the next crossover cutoff, then you get the higher grade. And the grades of others will remain undisturbed, and they will not be unfairly compared to your marks just because they have not taken, they have not opted for this extra. Now, at that time, we had not really started studying the subject matter, so it was not possible to immediately see what methods offer the possibility of programming implementation. So now that possibility is there. So that possibility, you on your own would get certain ideas through the lectures, through your study, and while doing the assignment problems, that wow, this method, this problem could be so nicely done through a program, computer program, with less trouble to me and with the possibility of generating much more output which can contribute to learning, my own and somebody else's also. So such problems, a little sample list of such problems I have tried to uh, spell out. So in lesson 1, in slide 3, what we are doing, let us see. So This is the conversion of a higher pair to two lower pairs and linking. So where should be the centers for those two additional divided pairs which we introduce. So this is instantaneous, you know. Now this thing can be nicely implemented in a program, but this is very small. So we will see the bigger ones also. Yes. So then lesson 5, slide 3. So slide 3, 4, whatever is the material, uh, that material can be nicely coded. So lesson 5, let us see lesson 5. Numbers. Okay. So number synthesis and steps can be very nicely coded in a computer program. And results which are much more extensive can be generated compared to what you could do uh, by just inspection and your own rough work and so on. Okay. And the computer program, through a computer program, you can do it better. And in fact, if you find that there is a slip, one possible aspect you can did not cover, then you can always make a little change in the program, and you will get it. Okay. So at this time, now most of that you do will be mostly for your learning, okay, and of course the bonus marks. That is aside. There was a time when precisely on this problem, people used to develop their PhD thesis and earn their doctorates. So that was a research problem once. Now also it is a good problem. It's a non-trivial problem. What's doing as a learning exercise and what's doing in order to teach others. Okay. So assignment 5 has one little sample of that, and lesson 5 has a little example of that. So that thing can be done for bigger mechanism, and all cases detailed work on that can be done as well. Then lesson 6. In assignment 6, you have done 6 um, configurations for a dash of 10 and another 6 configurations for a non-dash. Why 6? Why not less? Why not more? Why not a single one? So through 6, I wanted to ensure that you see several snapshots, a sufficient number of snapshots, so that you can get the picture of how the thing is moving. And 6 is actually limited for the purpose. Something like 180 or 360 or at least 60 could be better for that purpose. Through a program, you can do that. To that program, you can also keep on listing out the values and make plots. And why stop at plots? You can make an animation. And that will give you a lot of satisfaction. That will give you a lot of learning. And as you change the link lengths, the data of the problem, you will find how things change. This is a very revealing exercise. Then you can do that exercise. This was originally for forward. You can do that kind of an exercise for cyber also. In principle, you can possibly extend that kind of analysis to sequence mechanisms also. And the whole thing is a basic learning exercise. Whatever amount of it you do, whatever parts of it you do. Then lesson 7, slide 4, 5, in which, through which I have demonstrated to you how to locate different points of the mechanism in a particular configuration step by step by assembling a diag at every point. That thing is better done algorithm. Okay? And several things can be done in that lab. One is determining the order of locating points and links. Second is, immediate offshoot of that, to find out whether the mechanism is complex or not. And these 2 points, these two things can be done without knowing the link length. Just knowing which link lengths are known. When I say without knowing the link lengths, I basically mean without knowing the kinematic parameters. But if you are told that which link lengths and angles are available as kinematic parameters and which inputs, which position coordinates are given, then you can do these two tasks. Okay? And then if you are given the values of those kinematic parameters, then you can do more. You can go on actually positioning those points and links and thereby actually solve the entire mechanism configuration. If it is complex, then at a point you will set up an equation or more equations and solve them through the simple Newton relaxation solution, which you do. In case of complexity, that you will need to do. So in that you can run several. Once you develop the program, you can run several problems. In particular, you can include the assignment problem and see how it works. Now, then lesson 8, slide 4 shows you uh, algorithmically solving the final system by using the solver as well as by elimination. You can try an elimination kind of method through which you can develop finally a single variable polynomial equation in simpler cases. In lesson 9, I am talking about that reduction to a univariate polynomial. And to the extent possible, if you do that, to the extent possible, you avoid symbolic computation because no symbolic computation really should be done for a step, the ultimate intention of which is numerical computation. Then the whole thing should preferably be numerically done beyond whatever you do on paper with your hand. Okay. And some of the symbolic computation you can do numerically by representing the thing as a kind of function with coefficients you handle you. So that is a better way of doing it rather than just taking the easy way out and doing symbolic computation. The reason I will not explain to you because if you do that, if you once try symbolic computation, you will know on your own. I tried symbolic computation and then later I found that those expressions become so monstrous that it doesn't make very good sense to human. Now, synchrony we discussed in class. That is essentially a graphical method. But it is quite possible to implement that graphical method by calculations. So, as if a computer software to develop, to make drawings, scale drawings, is using some logic to find out the points, which have point coordinates. So, central method, as I tried to dry run in my mind, that if on a graph paper I want to place the points without really the compass protector, etc., etc. Okay. Then what background calculation I will need to do for this purpose. This is very nicely done, very straightforward, and you can explore how the graphical method based on centroids itself can be implemented as algorithmically. You will have a very interesting experience. And same thing you can do with velocity and acceleration diagram. Now, lesson 12 is iterative steps on of analytical methods for velocity, for position, velocity, acceleration, the whole thing. In particular, velocity and acceleration. So that is to begin with for programming implementation. We have done in class only, and in your exercise we have done only small problems, which could be solved on paper with pen. But that methodology you can actually implement in a computer program that has been designed for implementation in a computer program, and then track the problems for mechanisms as large as you can think, as large as you might need in a practical situation. Lessons 13, 14, 15 are on synthesis. So again here some little examples we tried in the class and in the assignment. But once you are writing a program, you can write for anything. Okay. The program may take input. Program may take as input what function you are going to handle for function generation. If can be any input function, or you can put it in a statement in the program. The domain to numerical data that can be certainly inputs. Okay. Then for the intervals of input and output coordinates theta 2, theta 4 say, they also are numbers, whether you put it in radians or degree, whatever it is. So they also can be taken as inputs. So one program you get, and development working out semi accuracy points 3, 4, 5, 6, 10, whatever you want, becomes just one mostly. And a few key steps. So in the same continuation, you can then also say that why only function generation? For path generation and motion generation problems also, how to parameterize, define and parameterize an error function for that, for which we will do this solution minimization kind of thing. You can do that also. Then in lesson 15, we studied dimensional synthesis through analytical methods, and they can be nicely implemented in theory. You can do that. Now, this much I myself spotted. One single brain. Now, you people have other brains, so you will possibly spot some other possible problems which can be nicely implemented through computer programs. Okay. And in the second half of the course, there will be many more such applications. So, and you can think of combining one or two of these together. Such scope is there very much. Okay. So, based on this, you can decide on which problem you would try to earn your bonus if you decide to do it. Now, as you get that kind of idea in mind, my suggestion would be that you write that proposal in a little paragraph, 2-3 lines, and send it to Peter. Okay. And this is basically in order to create a balance so that everybody does not try to do this, choose the same thing. So if you want to avail of this little problem, you can do anything. What I mean is that if you want to avail of the corresponding evaluation and the bonus credit, then you suggest to Vittal that you would like to do this. If you choose one of these as it is, then you mention you can directly refer to number 7, number 8, number 9 in this document. This document is sitting in the resources. Or if you want to combine two of them, you mention that. If you have got an idea on your own, either in the first half, which I might not have listed here, or in the second half of the course which have not been listed here in any case. Okay. So, and then after a little cross checking, Vittel will uh, clear that topic. On the other hand, if several others have already taken that, that is, if Vittel has similarly cleared such proposals from other students already, the same proposal, then he might say that this has been taken by someone or some quite a few people. You try to take something else. That's also possible. So once Vittel okays your proposal, then you nicely work it out, say over a month, and something like in the last week of October, you submit a report on this little research. Okay, I'm calling it research, though I'm not very sure that you will be able to publish a paper. This is primarily for learning. On the other hand, it is also possible that this little work you take to such heights that other than earning some marks out of the 50 bonus and improving your grade, it might happen that the work turns out to be so beautiful, so nice, that you can actually publish a little conference paper somewhere. Okay, even that is possible. This way, people do develop some lateral little conference papers. Those of you who are more academic minded, they might end up getting some advantage in their CV also. So it's up to you whether you do it or not, and if you do, to what extent, to what height you take, and what advantages you accrue out of that in your uh, course, general learning, and in general in your career. So this little thing I wanted to mention at this point, so that it does not happen that you got deprived of this interesting opportunity just because you did not remember the suggestion. Okay. So I think I'll stop at this point and this video I'll upload. Thank you.